Alright, this is the last section of Pre-Algebra, Chapter 9, Section 2, Performing Operations on Square Roots. We've done some operations on square roots, but you can actually do operations inside a radical or as fractions so that you can simplify things before you have to prime factor them or take the square root of them. So I'm going to do these examples off to the side so I have more room. This is example A. We have radical 12 times radical 2. Now we're going to do the opposite of what we were doing in the beginning of this section. In the beginning, we were taking two factors that were under the radical and we were putting them in two separate radicals. Now, they're already in two separate radicals, but we want to put them under one radical so that we can multiply them. So we're going to do 12 times 2, and then we're going to simplify to radical 24. Now, we are going to simplify. We have to simplify. So you can do perfect square factors or you can do prime factorization. I am going to do perfect square factors for this one because it's a small number. So perfect square factors would be 4 times 6. Radical 4 times radical 6 would equal, square root of 4 is 2. Can't do anything with radical 6. So it stays radical 6, and our final answer is 2 radical 6. So radical 12 times radical 2 is 2 radical 6. Now there are other ways to look at this as well. So we could have taken these two things separately. Radical 12 times radical 2, and we could have simplified radical 12, which would be 3 times 4, so that would be radical 3 times radical 4, which would give you radical 3 times 2, which would give us 2 times radical 3, and then we would bring down this radical 2. And then bring down the 2. Both of these are in a radical, so you can put it under one radical, and you would get 2 radical 6. Pretty much the same thing. It depends on how much you would like to simplify. Let's look at example B. This is a quotient property problem. If we use the quotient property, we have B, we have radical 18 over radical 10. Now we could easily simplify both of these and then simplify some more until we have the fully simplified problem. But the easiest way to do this would be to first put them both inside the radical, one fraction, and notice that 18 and 10, the numerator and the denominator, are both even. We can simplify this before we even start. So we are going to get radical 9 over 5. Radical 9 over 5, which becomes radical 9 over radical 5, which becomes 3 over radical 5. Now, this is a problem because there's a radical in the denominator. So we do have to rationalize the denominator, but it's not too bad, I promise. Rationalizing the denominator just means that you have to get rid of that radical. So all you have to do is multiply by the denominator. So I am going to make this new fraction that is just the denominator. I'm going to multiply by radical 5 over radical 5. When we do that, we get 3 times radical 5, which is 3 radical 5, over radical 5 times radical 5, which is radical 25. And then when we simplify, we get 3 radical 5 over 5. 3 radical 5 over 5 is your final answer. There we go. We have A, a multiplication problem, and B, a division problem. Product property and quotient property. Example 2. adding and subtracting. So when you add and subtract, you have to treat these kind of like variables. When you add and subtract variables, you can only combine like terms. When you add and subtract radicals, you can only combine like terms. So for this first example using addition and subtraction, let's use the commutative property to put our like terms together. What are our like terms? We have 5 radical 6 and negative 4 radical 6. These values have the same number inside the radical, so those are our like terms. So we have 5 radical 6 minus 4 radical 6 plus 3 radical 2, which doesn't have any like terms. 5 radical 6 minus 4 radical 6, we would do 5 minus 4 times radical 6. It's just like a variable. We're treating this radical just like a variable, so we're not doing anything with the variable. We are just subtracting the coefficients. When we subtract these coefficients, 5 minus 4, we get 1. We get 1 times radical 6 plus 3 radical 2. 1 times radical 6 is just radical 6. So our final answer is radical 6 plus 3 radical 2. We can do the same thing with example B, even though it doesn't appear that we have anything with a radical in common. So there's no, air quotes, like terms. But we also know that radical 12 can be simplified. So before you start adding or subtracting, you have to simplify anything that can be simplified. So radical 12 can be broken into radical 4 and radical 3. So we are going to do 9 radical 3 plus radical 3 times radical 4. Now we're going to use the product property. 9 radical 3 times radical 3 times radical 4. And we know that the square root of 4 is 2, and radical 3 will stay radical 3. So now we can actually add these two because they are, in fact, like terms. 9 radical 3 plus 2 radical 3. So we're adding 9 plus 2 times radical 3. 9 plus 2 is 11. Our final answer is 11 radical 3. Now we have some checkpoint problems. Let's see how well you do performing operations with these radicals. So pause the video and come back when you're ready. Remember, if there's no like terms when you're adding or subtracting, simplify first. Simplify first. There will be like terms. All right, here are your solutions. For number 1, radical 12 times radical 6, I put both of those inside one radical as factors, and then I prime factored them each separately. And then I took out the pairs. 2 and 3 came out, and you are left with 6 radical 2 as your final answer. Number 2, if you put 48 and 21 inside one radical, you are left with radical 16 over 7. The square root of 16 is 4. The square root of 7 is square root of 7. So that stays in the denominator. That means you have to rationalize the denominator by multiplying it by itself. So we multiplied 4 over radical 7 times radical 7 over radical 7 to rationalize the denominator. And we were left with, after simplifying, 4 radical 7 over 7 as our final answer. Number 3 gave the appearance of not having any like terms, but it does. You just needed to simplify radical 8 first, and radical 8 can be simplified into greatest common factor, perfect squares, or perfect square greatest common factor. 5 times radical 4 times radical 2 is the same as saying 5 radical 8. The square root of 4 is 2, so 5 times 2 is 10. 10 radical 2. So 5 radical 8 can be simplified into 10 radical 2. 10 radical 2 plus 6 radical 2 equals 16 radical 2. And the last one was probably the quickest of all of them. You needed to use the commutative property to rearrange this expression so that the radical 3 terms were next to each other. So 8 radical 3 minus 1 radical 3 minus 3 radical 11. 8 minus 1 is 7, so 7 radical 3 minus 3 radical 11. They are not like terms, so this is your final answer, and this is the end of 9.2.